All right, guys, so I'm jumping right in because I don't want to have to make more than one video. I can only use 15 minutes at a time for this free app. So this is implicit differentiation. And your instructions for this particular problem, this comes from section 3.8, and it is asking for the second derivative. Right, so finding the first derivative is pretty easy. The first derivative, just like we've always did, for this particular problem would be 10y. But now because it's implicit differentiation, we have to do our dy over dx minus. Now this middle part, we do our product rule, so it's my first times the derivative of the second. The derivative of y is 1. So that would be 1 dy over dx. So it's the first times the derivative of the second plus the second times the derivative of the first. And we have to understand that because I have a minus in front of that xy that I really need to put brackets there to distribute that negative. And that plus 3x squared would be plus 6x, and the derivative of 4 would give me 0. And I guess I should skip lines because that looks a little jumbled up. But what I'm going to do here is I want to solve this equation for dy over dx. I want to get the dy over dx by itself. I want to isolate it. So what I would do first, let's skip some lines here so it'll look neater. We have our dy over dx. What I'm going to do here is distribute that minus sign. I'm going to distribute it through those brackets that I have there. So that would give me negative x dy over dx minus y plus 6x is equal to 0. And what I'm going to do is move everything I have without a dy over dx across that equal sign. So that would leave everything with a dy over dx to the left. And on the right hand side, I could rewrite that as y is not equal to, slow down Latoya, y minus 6x. Now I want to isolate that dy over dx. I've said that a couple times already, and we can look at that as a common factor. So what I'm going to do is I'm going to factor out that dy over dx. And if I do that, what that's going to leave me with is a 10y minus x on that left-hand side. And I'm just going to leave my right-hand side essentially the same. And to isolate that dy over dx, I would divide both sides by that 10y minus x. Now those are going to, oops, I don't want to erase. I think it thinks I'm erasing when I go really fast. So that's going to reduce, and that's going to leave me with dy over dx is equal to y minus 6x all over 10y minus x. Now guys, what we just found was the first derivative. Now if you look at what I put up here at the top for this particular problem, it is actually asking for the second derivative. So what I'm going to do is slide this over, and I'm going to find the second derivative. Let's use a different color. So now my second derivative is going to be found by finding the derivative of of my first derivative, which we already know. But that's we're going to have to apply the quotient rule there. Um, so my second derivative, and if I am a good teacher, I would write it this way. My second derivative is going to be equal to the bottom. I think I can slow down a little bit. This is what I really want to let you guys look at and think about. And remember, you can always pause this video when you need to. So it's the bottom times the derivative of the top. The derivative of the top is going to be 1 dy over dx minus 6 for the bottom times the derivative of the top minus the top times the derivative of the bottom, which is going to be 10 dy over dx. Let's put that in parentheses so I can find it a little bit easier when I'm looking for it. Minus 1. Now, guys, honestly, you did the calculus. The hard part here is the algebra. Um, It's tedious. You have to pay attention. You have to take your time. But everything else here from here on out is just strictly algebra. So the second derivative is going to be equal to, um, let's see, what can I do here? I want to get rid of this minus sign and I want to multiply everything out. I want to write it in expanded form. So I have to use my distributive property. We're going to use our full method. So that would give me 10y dy over dx minus 60y minus x dy over dx, and I should slow down. I got that. I got this middle part from multiplying 10y times negative 6, and this minus x dy over dx came from multiplying those two middle terms together. And then if I multiply those two last terms together, that's going to give me plus 6x. And I'm going to put that in parentheses just to keep everything nice, neat, and in order. I'm going to drop down that minus sign, and I'm going to apply that FOIL method again, my FOIL method or my distributive property. And if I do that, my first two terms there, oops, I don't want to highlight it, but my first two terms there, if I multiply them together, that's going to give me my 10y dy over dx. My two outside terms is going to give me minus y. My two inside terms is going to give me minus 60x. And again, I have that dy over dx. And then I have my two last terms there, which is going to give me plus 6x. Now, all of that, guys, is, and I hope you paid attention because I forgot something in that first step, and I don't know how I did not write that down. I'm going to give you a minute to think while I'm writing it. But if you notice, with my quotient rule, I'm so worried about my algebra. And I knew in my head that that all of this is over 10y minus x squared, but I didn't write it down. So please, please, please go back up here and put all of that all over my denominator squared. We cannot leave that off. Okay, even though I want to save me from having to write so much, I need to write it down, and you guys do need to do the same so that we don't forget it. Now from here, all I'm going to do is combine like terms in my numerator. I'm going to simplify it. I'm going to slide this over so I can get a better look at it. And what I notice is that I have this 10y dy over dx and a minus 10y dy over dx. So I'm just going to cross those out because they're going to cancel one another out. And then I have, I thought I had something else in common. I have my 6x and my 6x. They're going to cancel one another out. And I think that's it. But what I do have left are some common terms up there. And if I rewrite that, combine my common terms, that's going to leave me with, I have a negative 6y, negative 60y minus a negative y. So that's negative 60 minus a negative y, which is negative 60y plus y, which leaves me with a negative 59y. And then I have, let's choose a different color, negative x dy over dx, and minus negative 60x dy over dx. So what that's going to leave me with is plus 59x dy over dx. And let's stick that in parentheses. And again, let's not forget, because I'm bad for wanting to leave off my denominator, which is that 10y. My screen glitched. I'm sorry, guys. 10y minus x all squared. Now, I did say that everything else was algebra. I guess I kind of did tell a little story there. I apologize. Um, because you do have one calculus concept we have to understand here. We're finding the second derivative. And if you notice, I kind of found it, but I have something wrong. I have a dy over dx in there. That doesn't look right, right? When we find the second derivative, we just want variables, just the x and the y. I don't want to see a dy over dx. But it's okay because we know what dy over dx is. And because of that, what I can do is take what I know dy over dx to be, and I can substitute that into its place, and I can simplify. So in calculus, guys, when you're not sure how to finish something, if you know what something's equivalent to, if you know its value, you can always substitute to see if you can get things to work. That's what we're going to do here. Um, so my next step here, and this is tedious, it is, we have to take and substitute what we know that dy over dx to be equivalent to, and dy over dx is equivalent to that y minus 6x all over 10y minus x. And guys, I know this is going to look a mess, but all of that is still over my 10y minus x whole squared. Now, because I want to be lazy and I don't want to make too much of a mess, I have a little trick for combining fractions, which is technically what I have. But before I combine this negative 50y and this fraction on the right, what I want to do is I'm going to take and distribute that 59x into that parentheses there. Um, so that would leave me with d squared y all over dx squared. So that's my second derivative of y with respect to x is going to be equal to negative 59y plus 59xy minus 354x squared all over 10y minus x. And let's remember all of that is all over 10y minus x all squared. And honestly, I worked this out beforehand to make sure I didn't make any mistakes or I didn't get on here and make a mistake. And what I honestly did is I kind of left that denominator off until the very end. But I'm running out of time, so let me hurry up. So what I would do, guys, for me, what's simple for me, is to take this 59 over y and pretend there's a 1 there, and I'm going to cross multiply to combine those fractions. And that would leave me with, let's color coordinate this, okay? So I'm going to multiply it this way. And if I do that, that's going to give me a negative 590 y squared plus 59xy. I'm going to bring down that plus sign, and then I'm going to cross multiply the other way. That 1 times all of that, so that's just going to be plus 59xy minus 354x squared all over 10y minus x all over 10y minus x all squared. Now guys, I'm gonna speed up a little bit, but if you combine those like terms in the numerator, that's going to give me a negative 590 y squared plus 118 xy minus 354x squared. And because I'm dividing by a 10y minus x and then dividing by 10y minus x all squared, remember I've explained this in class before, but what's going to happen here is that it can be rewritten as 10y minus x to the third power. And I have a few seconds left, and it's probably going to cut me off, but I think you can finish. But my final answer is 118, a negative 118, 5y squared minus xy plus 3x squared, all divided by 10y minus x all cubed. And there you have it, with a few seconds to spare.